Hi, and thank you for tuning in to Gavin Lon Digital. I'm Gavin Lon. So, in the last two tutorials, i.e. parts 19 and 20 of this course, we created a facility whereby an administrator can match registered users with courses. So at the database design level, the relationship between registered users and categories, which in the context of this application are courses, is established within the user category database table. The user category table is a join table and facilitates the many-to-many relationship between the ASP.NET Users Identity table and our category custom table. So in this tutorial, the primary focus is on implementing the code so that when a registered user logs onto the system, the courses with which the user has been matched are displayed to the user. In terms of user experience, this means the user is only presented with the courses of interest to the user, so this provides convenience to the user. The course and relevant course items will be presented to the user, whereby the course headings are immediately displayed, but the course items, which will contain links to the relevant course content, are at first hidden, i.e. collapsed. To access relevant course items, the user can click the relevant course heading, which will result in the related course items being displayed directly below the relevant course headings. The user is then able to click a course item link to access the relevant content. For content like this and much more, please consider subscribing, and please ring the bell so that you'll be notified of future content. If you like this video, please give it a thumbs up, and please share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description. It will be greatly appreciated. So this tutorial is made up of 3 parts. Part 1. Create the Category Item Details Model view model, the Grouped Category Items by Category Model view model, and the Category Details Model view model. In this part, we'll create 3 view models. We'll create a user-defined type for representing a view model named Category Item Details Model. This view model represents relevant details regarding a particular category and related category item. We'll then create the Grouped Category Items by Category Model view model. This view model will be used to store data for a category along with related category items. So for example, this model could store a course or category with the title of C# for Beginners, along with related category items that have the following titles. For example, Introduction to C#, C# data types, C# variables, etc. This view model could also be used to store data for a course named Advanced C#, along with its related category items, for example, C# delegates, C# generics, C# attributes, etc. We'll then create a view model named CategoryDetailsModel. This view model will be used for storing a collection of grouped category items by category model objects, as well as a collection of category objects. Note that in this tutorial, the focus will be on the collection of grouped category items by category model objects. Part 2. Update the HomeController class. In this part of the course, we'll write code for the HomeController in the default area, i.e. within the relevant index action method, that creates list category items grouped by category and then passes this data to the relevant home index view. Part 3. Update the home index view. In this part of the tutorial, we'll write the necessary C# code to loop through the collection of grouped category items by category model objects and output the relevant HTML and Bootstrap code to display the relevant data to the user. The Bootstrap code will facilitate a dynamic user interface whereby the user can expand and collapse the grouped courses items by category. Part 1. Create the Category Item Details Model view model, the Grouped Category Items by Category Model view model, and the Category Details Model view model. So let's create a new class in the Models folder in the default area and let's name this ViewModel class CategoryItemDetailsModel. Let's create an integer property named CategoryID. Let's create a string property named CategoryTitle. Let's create an integer property named CategoryItemID. Let's create a string property named CategoryItemTitle. Let's create a string property named CategoryItemDescription. Let's create a string property named MediaImagePath. So let's create a new class in the Models folder in the default area, and let's name this view model GroupedCategoryItemsByCategoryModel. Let's create an integer property named ID. Let's create a string property named Title. Let's create a property named Items. Note that this property is of type iGrouping and is strongly typed with integer, and the type that we have just created, our user-defined type, i.e. our view model named CategoryItemDetailsModel. So let's create a new class in the Models folder in the default area, and let's name this view model class CategoryDetailsModel. Let's create a property of type IEnumerable that is strongly typed with our user-defined type GroupedCategoryItemsByCategoryModel, and let's name this property GroupedCategoryItemsByCategoryModels. Let's create a property of type IEnumerable that is strongly typed with the category type, i.e. the type that represents our category entity. And let's name this property Categories. Part 2. Update the HomeController class. Let's open the HomeController class within the default area. So the first thing we need to do is write code to pass in 3 objects via dependency injection through the constructor of this class. So this argument represents our database context object. This argument is of type sign-in manager, a type provided by identity, and we are strongly typing the sign-in manager type with our application user type. The application user type represents a user in the system and maps to identity's ASP.NET users database table. Remember that we created the application user class and it inherits from identity's identity user class. Note that we must assign the objects passed as arguments via dependency injection to this constructor to their respective counterpart read-only member variables. So within the index action method, we are going to write code to retrieve details about the category and category items with which the logged on user has been matched. So only the categories that have category items with associated content with which the logged on user has been matched will be passed into the relevant index view and subsequently displayed to the logged on user. So within the index action method, let's write code to check if the user is logged into the system. So we can achieve this in code like this by using the sign-in manager object, passed into the controller class via dependency injection. We can then capture the currently logged on user's ID. This ID value will be the primary key value for the logged in user, which is stored in Identity's ASP.NET Users Identity table. And we can capture this user ID by using the user manager object like this. The user manager object will be passed into the constructor of this class via dependency injection. So now that we have written code that gets a reference to the currently logged on user, we can implement a link query that queries the database for relevant category data with related category item data. The category, of course, must be matched to the currently logged on user. Note that at the database level, a category may contain category items that do not yet have associated content. So we only want our link query to bring back those category items that have associated content. Remember, the category item entity has a one-to-one relationship with the content entity. A category item either has one item of content or does not have an item of content. Let's create a private method named GetCategoryItemDetails for user that will contain our link query. This method contains one parameter named user ID. So the currently logged on user's user ID will be passed as an argument to this parameter. This private method returns an IEnumerable collection that is strongly typed with our CategoryItemDetailsModel user-defined type. So the returned value from our private method will be the IEnumerable collection object result returned from the link query we are about to write within our GetCategoryItemDetails for user private method. So let's write our link query. So we want to join the category item table to the category table and then the content table because we only want to return category and category item data if the relevant category items have related content. Then we must join to the user category table so that we only retrieve data relevant to the logged on user. We only want category data returned that has been matched to the relevant user within the user category database table. We are also joining to the media type table because we want to get the media type image path so that we can display an image next to each category item on the front end. This media type image indicates the type of content associated with the relevant category item. For example, if the content contains a video, we want to display an image representing a video next to the relevant category item. If the content only contains text, we can, for example, display an image representing a stack of newspapers. Then we can include a where clause that filters the data on the user ID passed into our private method. Lastly, we can populate our IEnumerable collection of category item details model objects with data using the select clause within our link query like this. So let's use the toListAsync method to convert our data to a strongly typed list of category item details model objects. So we are returning a strongly typed list of category item details model objects to the calling code. Then we want to write another link query that performs a transformation on the data returned from the GetCategoryItemDetailsForUser private method that we have just written. So we want the data to be grouped by category ID, so that the data can be displayed in the index view in accordance with our requirement. We want our data grouped by category. Remember, we want our data displayed to the user in a collapsible list. So basically, a list of categories is first displayed to the user. The user can click on the relevant category, and a list of category items is displayed immediately below the relevant category. The user can, of course, collapse and expand relevant category items at will by clicking the relevant category displayed within the browser window. So let's wrap the link query that we'll use to group the data returned from the GetCategoryItemDetailsForUser method by category in its own private method. Let's name this method GetGroupedCategoryItemsByCategory. So this method accepts an argument of type IEnumerable that is strongly typed as CategoryItemDetailsModel. So the argument passed into this method will be the result returned from our GetCategoryItemDetailsForUser private method. So let's write the code for the link query for this private method. And it is as simple as this. We simply use link's group by operator to group our data by category ID. Let's go to the calling code. Let's write code to assign the result returned by the GetGroupedCategoryItemsByCategory method to the relevant property of the object that we'll pass as an argument to the corresponding index view. So we could write code to return the appropriate view and data from the indexAction method like this. Part 3. Update the home index view. So we can now write the front-end code returned by the relevant controller's indexAction method, i.e. the code we have implemented in Part 2 to display the category and related category item data in a collapsible list. So let's open the home index view within the default area. Let's strongly type our view with our CategoryDetailsModel view model user-defined type. This is the object type that will be returned from the corresponding indexAction method in the controller class that we created in Part 2 of this tutorial. Let's write code to check if the grouped category items by category models property on the model object is not null. If this property value is not null, we want to execute code that traverses the IEnumerable collection stored within the grouped category items by category models property. Within the outer for each loop, let's output the relevant category data, i.e. the category title for each category is outputted within the outer loop. We are using the category ID to uniquely identify each category displayed to the user in this Razor view. We are using a Bootstrap card for layout purposes. I've included a relevant link below in the description for those of you who would like to read more about Bootstrap for cards. Then let's create an inner for each loop. Within the inner for each loop, let's write code to output data pertaining to each category item related to the relevant parent category. The data pertaining to the parent category is outputted in the outer for each loop. Note that we are using the category ID value for each category as part of the ID attribute value for each div element that encapsulates the relevant category data. We are using the data-toggle attribute and data-target attribute within the div element encapsulating the category data to implement a collapse effect, whereby a user can expand and collapse the category items associated with each category. Let's test the code. Okay, and we are presented with a nasty error message. So the exception message is essentially saying that our _user login partial view requires a model object. So this exception was caused by the fact that we have now strongly typed our home index view. So the exception message is essentially saying that our underscore user login partial view requires a model object. We can fix this issue by initializing our underscore user login partial views required model object through the use of the model attribute within the relevant partial helper tag, used for rendering the underscore user login partial view from within the index parent view. So let's run the code. And this is an expected result. We need to make a similar fix for the code that renders the underscore user registration partial view from within the home index parent view. So to fix this issue, let's appropriately initialize the model object for the underscore user registration partial view. Let's run the code. Great, we have fixed our issue. So I'm going to register a new user, James. Let's log on as administrator and match our new user, James, with his courses. So let's log on to the system as James. Excellent. For content like this and much more, please consider subscribing. And please ring the bell so that you'll be notified of future content. If you liked this video, please give it a thumbs up and please share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description. It will be greatly appreciated. I really enjoy reading your comments, so please feel free to engage with me in the comments section. The latest code can be found on GitHub. I've included a link to the relevant repository below in the description. Thank you and take care.